I tried so hard and got so far, but in the end, it doesn't even matter. I had to fall to lose it all, but in the end, it doesn't even matter. I tried so hard and got so far, but in the end, doesn't even matter. I had to fall to lose it all, but in the end, it doesn't even matter.
Okay, class, we continue to the next example. The periodic function is given by fx equals to from -3 to 0, fx equals to 0, and then from 0, x from 0 to 3, you have fx equals to x. So that here you have the idea that the function is defined over the interval -3, okay, to 3, right? So that this is can be matched, okay, to the our previous knowledge that the function is defined over the interval -L to L. And then notice that -L equals to -3 and then L equals to 3, so that we can conclude that our function L equals to 3. Okay, otherwise you can refer to the notation here. Okay, the notation here is fx plus 6. X plus 6 means that your 6 to L equals to 6. Therefore, you can conclude that L equals to 3. Just the same thing as the previous knowledge that we have. Alright. So, first of all, to avoid any confusion, you can eliminate this one from your function, because this is not being calculated after this. Fx plus 6 is just to show that you have a periodic function, but this is not being calculated, okay? So we continue. The first question asks you to sketch the graph of the given function over the interval x from -9 to 9. So eliminate this one first, just avoid, okay? So just read as sketch the graph of the given function. So this is your function, okay? This is your function. So from -3 to 0, your fx remain unchanged as 0. So you have this one. And then from 0 to 3, from 0 to 3 here, okay, over this interval, fx equals to x. So fx equals to x. When x 0, your fx is 0. Titik sini. Okay, when x equals to 3, your y-axis or your fx is also goes to 3. So this is the point. So fx equals to x is just like y equals to mx plus c, just a linear function, linear graph. Okay, so that you have this kind of line. Okay, so this is your initial function or the single function, but the question asks you to extend the function over the interval -9 to 9. So this is 3 to 3. Okay, from 3 to 3, the limit or the interval is 6 units. So 6 units is your period, okay, your period. So that we continue. 3 units here, 3 units lagi. So sebab saya buat dia punya scale is 3 unit, okay. So 3 units is this one, okay. So I put this one, and then the other 3 units is like this. Okay, so that is why we get from 0 to 9 like this lah. Okay, then we proceed to the left. So from the left, just freehand. So the shape just like this. So I have the idea that I need to continue at this point. So like this, and then continue like this. So this is the periodic function. This is how you try to sketch the graph. Freehand, okay, freehand, but with the correct limit or correct interval. Okay, so the question 1 or question A is done. Next, determine whether the function is odd, even, or neither odd nor even function. So look at the single function here. When you try to fold at y-axis, you will find that the graph is not symmetrical to each other. When you try to fold at y-axis at origin, any point of the origin, okay, even though sini pun, you will find that the graph, okay, the function here and here is not symmetrical. So we can say that you have neither odd nor even function, neither odd nor even function. If the question asks you to state your reason, or the question asks you to verify or justify your solution, you can say that this function is not symmetrical neither at origin or at y, nor that at y axis. Macam itulah. So kita define seperti mana bukan odd dan bukan even, right? So next we continue. Find the Fourier series of the given function. Since this is neither odd nor even function, so that we need to apply the first one or the general formula. Mana general formula dia? The general formula is here. Okay, di sini. The general formula is here, so that you need to apply the formula. So you cannot just simply calculate at one side and then multiply by 2, but you need to calculate both sides of your function, because both sides of your function are different. So it's okay. So we continue. We know that the Fourier series is given by fx equals to a naught over 2 plus summation n from 1 to infinity an cos n pi x over L, okay, plus bn sin n pi x over L. Okay, so this is your Fourier series. So now we begin our calculation by finding what is our a naught. Okay, so a naught. A naught is given by 1 over L, okay, from negative L to L, fx, fx dx only. Okay, fx, okay, fx and then dx. Alright, so L, what is L? L is 3. So you will have 1 over 3. From negative 3 to 3, fx dx. From negative 3 to 3, you have two functions. You have two functions, but the first function is 0. When you substitute fx equals to 0 here, 0 times anything will go 0. So we don't want to calculate for the first one because your fx is already 0. So this is quite a simple question. Okay. fx equals to 0, so we are very happy. I'm so happy because fx is 0. So it will reduce my time to calculate for the first function. We go to the next one. Okay. So fx equals to x when x from 0 to 3. Okay. So this one saya tulis lah 1/3. Okay. From 0, sorry. From negative 3 to 0, I have 0 dx. Plus from 0 to 3, I have apa tadi? X. Okay. fx is x dx. Close this one. Okay, so this one goes 0, tak payah calculate, and then we continue. 1 over 3, integrate from 0 to 3, x dx. 1 over 3 is 1 over 3, okay. So integrate x will get x squared over 2, and the limit is from 0 to 3. So I have 1 over 3, substitute 3 first, so you have 9 over 2 minus 0. So you have dengan ni tadi kita dapat apa? 3. So your solution is 3 over 2. So A naught is 3 over 2. So A naught is 3 over 2. A naught is 3 over 2. Divide by 2, so that you will have, here is 3 over 4. Okay, so now we continue. We want to find out what is an, and then we plug in the solution here. Okay, so an is given by 1 over 3. Okay, L is 3. And then we have from negative 3 to 0, fx is 0 dx. Plus from 0 to 3, your fx is x. Okay. Oh, sorry. For cos, for an, saya kena tunjukkan satu-satu because this is our first attempt to solve for this one. Okay. 0 times cos n pi x over 3 dx. This is ultimately 0. Okay, and then don't forget to plus from 0 to 3. Okay, you have x times cos n pi x over 3. And as I mentioned, next to x saya suka buat dalam kurungan because this is our constant, okay, dx. Alright, so kita bagi dia cantik, okay, 1/3 integrate from 0 to 3 x cos n pi x, okay, over 3 dx. This is a polynomial, and this is a trigonometric function when we try to integrate, okay, these two functions, so that we apply the integration by parts or tabular method. So apply the tabular method here, plus u dv x cos n pi over 3x. Okay, saya suka letak macam tu supaya saya tak confuse whenever I want to integrate. So bila kita integrate, we will bring the constant here downward, right? Okay, so differentiate x will give us 1. Integrate cosine is positive sign. Sine. Just copy. Integrate cosine is sine. So cosine n pi over 3x is sine n pi over 3x. But this is a constant. So sebenarnya kita kena bahagi bawah ni tau. Bahagi dengan n pi over 3. Divide by n pi over 3 is equivalent to times 3 over n pi. So that is why saya akan letak kat sini 3 over n pi. Sebenarnya dia per over n pi over 3. So n pi over n pi over 3 is equivalent to times 3 over n pi. Okay, that is the idea. Tapi saya bawa dia ke sebelah supaya saya tak nak confuse. This n pi over 3 and 3 over n pi cannot be cancelled out. Okay, so we continue. 0. Integrate sine will always get negative of cosine. So copy. Cos n pi over 3x and then times again 3 n pi to here. So you will get 9 over n square pi square. So macam tu, okay. So plus and minus. Okay, so now we will get 1/3. 1/3. This one positive, 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 positive. So we get positive 3x over n pi sine n pi over 3x. X ini jangan darabkan dengan x belakang, salah. Okay, this is for sine. Sine n pi over 3x. You need to multiply x dekat depan, in front of the sign. Bukan dekat belakang, in front of the sign. So that is why I put 3x here. Okay, and then this is positive and then minus minus plus is positive, so you will get plus 9 over n square pi square cos n pi over 3x. Limit from 0 to 3. Okay, so we continue. 1/3 is 1/3. Okay, 1/3. And then substitute 3 first. Okay, substitute 3 here, you will get 9 over n pi sine. Okay, sine. Substitute 3. Masukkan 3 dekat sini. Apa dia? Kita punya x kan? So masukkan 3. Oh, 3 dengan 3 ni boleh cancel out, okay? Okay. Cuma yang ini je tak boleh cancel out dekat depan ni. Okay, but this one, dia satu kumpulan. 3 and 3 here, you can cancel out so that you have only sine n pi. Sine n pi apa? Sine n pi is 0. So this one goes, the first one is 0. 0 and then plus. This is the upper limit, upper limit. So this one is 0 plus the upper limit. This is upper limit, 0 plus 9 over n square pi square. Masukkan 3 dekat sini. Okay, this one is 3. So 3 over 3 is 1 cos n pi. Maksudnya 9 over n square pi square times cos n pi. Cos n pi apa? Negatif 1 kuasa n. So this is your upper limit. Minus the lower limit class. Lower limit, masukkan 0. So masukkan 0 kat sini. 3 kali kosong is 0. So you get 0 again. Okay, plus 9 n square pi square. Cos, masukkan dekat sini tadi 0. So cos n pi over 3 times 0 is cos 0. Cos 0 is not 0. Cos 0 is 1. Okay, so you get this one. Cos 0 is 1. So we continue. So I have 1/3. So dekat sini saya ada 9 per n square pi square. Negative 1 to the n. Okay, and then I have minus sign, okay. Minus 9 over n square pi square. Okay, so n square pi square, n square pi square. So saya ada 3 dekat sini. So 3. So kalau saya factorize semua so saya ada 3 per n square pi square negative 1 to the n minus 3 over n square pi square. So if I can try to simplify this one, I will get 3 over n square pi square. Okay, so saya ada negative 1 to the n minus 1. Okay, so this is my an. So my an is 3 over n square pi square. Negative 1 to the n minus 1. Okay, so we go back to the function here. Okay, so saya ada what is my n just now. Okay, saya harap saya copy betul lah jawapan ni. So my an is 3 over n square pi square. Okay, negative 1 to the n. Okay, negative 1 to the n. Negative 1 to the n. Okay, minus 1. So that is my an. Don't forget to times with cos n pi x over L. Over L is 3. Okay, so next I want to find what is my bn. Oh, tak habis lagi. Alright, so we try to find our bn. So bn is given by 1 over 3 limit from negative 3 to 3. Okay, fx sine n pi x over 3 dx. Okay, so saya ada 1/3. Okay, from negative 3 to 0, I know that the function is 0 just now. Kita dah buat benda yang sama. So, kita sambung je lah. 0 from negative 3 to 0, negative 3 to 0, fx is 0. So, no need to calculate for that. So, we continue. From 0 to 3, my fx just now is, apa tadi? Okay, fx. Fx equals to x. So, we have x sine n pi x over 3. So this is just the same thing as what we have calculated before. Okay, but the difference is just on the sine and cosine. Okay, so we continue. U dv, this is x, this is sine n pi x over 3. Duduk dalam kurungan diam-diam. Okay, differentiate x, we get 1. Integrate sine is negative cos, copy balik n pi x over 3. So what are the constants here? The constants are n pi over 3. So when you divide by n pi over 3, you will get times 3 over n pi. Okay, continue. 0. Integrate cosine is positive sign, but you have negative sign in front of here, so you get negative juga lah. So you have sine n pi over 3 x times again 3 over n pi, you get 9 over n square pi square. So alternate plus minus sign plus, and then this one is minus. So I have 1/3. Negative, positive, negative, positive, positive. So you get negative 3 over n pi cos n pi over 3x. Okay, and then negative, negative, positive. So positive 9 over n square pi square sine n pi over 3x. Limit from 0 to 3. So I try to substitute 0 to 3. Substitute 3 first. So substitute 3. The first one So substitute 3. So this one is 3. So cos n pi 3 over 3 is cos n pi. So I will get 1 over 3 here. Negative 3 over n pi. This one, the first one. Okay, the upper limit. Okay, the upper limit. I will get negative 1 to the power of n. Because cos n pi. Okay, so I substitute 3 again here. Okay, 3 again here. So I will get sine n pi 3 over 3. 3 over 3 can be cancelled out here. 3 over 3. Okay. Please wash. 3 over 3 can be cancelled out so that you will get sine n pi. Sine n pi is 0. So this one is plus plus 0. So this is your upper limit minus the lower limit. Bila masukkan 0 here, okay, cos n pi over 3 times 0 is cos n pi 3 over 0 is cos 0. So cos 0 is not 0, cos 0 is 1. So you will get negative 3 over n pi times 1. Okay, when you substitute x here equals to 0, sin n pi over 3 times 0 is sin 0, sin 0 is 0. Okay, so that I will get 1 over 3. Dekat sini kita ada negative 3 over n pi, negative 1 to the n. Okay, negative negative is positive, plus 3 over n pi. Okay, so 3 ni boleh simplify, so that I will have 1 over n pi, okay, minus negative 1 to the n. Okay, sini tinggal 1 per n pi kan, so 1 per n pi, tolak 3 ni dah cancel out dengan yang luar tadi tu, so I have minus negative 1 to the power of n. Okay, jangan lupa n pi. So I can simplify this function as, this solution as 1 over n pi. Okay, 1 over n pi, so factorize, and then dalam ni saya ada 1. Okay, tolak negative 1 to the power of n. Otherwise, you can put this one as 1 over n pi. Okay, 1 plus negative 1 power n plus 1. So sama saja. Either this one or this one, your solution. Okay, so let's say to avoid any confusion, you just put like this as your solution, or if you put like this is also good. Okay, so 1 over n pi, 1 tolak. Okay, so that here I have bn. Saya dah ada bn plus bn is 1 over n pi. Okay, 1 tolak negative 1 to the power of n. This is your bn times with sin n pi x over L, which is 3. This is your Fourier series. This is your Fourier series. If the question asks you to find the Fourier series up to n equals to 3, so you will break this one lah, the summation function. Okay, but don't forget to plus dot dot dot. Okay, otherwise the question can ask you find the Fourier series at point x equals to, at point x equals to 0 lah contohnya, at point x equals to 0. So what you need to do is you put the summation and then letaklah x ni sama dengan kosong. Okay, so that is your solution. Okay, just substitute. Tapi the most important part is you need to find out what is your Fourier series lah. So how to get the Fourier series? So find out what are your a naught, an and bn, and then plug in into the formula, into the general formula. So that is how you get the Fourier series. So that is the end of our second example in this video. Okay, I will try to explain another one example, probably on what we call it, odd function. Okay, odd function in the next video. Thank you.